Open almost any mathematics or physics textbook and you will enter a world populated almost exclusively by European names: Pythagoras, Pascal, Snell, Newton. These names become so familiar that we rarely stop to ask a simple question: were these people really the first to discover the ideas carrying their names? In many cases, the answer is no. Long before the names we memorize today were born, mathematicians in Persia, China, India, and Babylon were already working with the same numerical patterns. Part 1. A name is more than a label. When a law carries a name, that person becomes part of humanity's collective memory. But what happens when the forgotten come from civilizations outside the West? European scientists remain celebrated individuals. Everyone else often becomes a generic phrase: ancient knowledge, civilizations without faces. Part 2. Was it really Pythagoras' theorem? Most students encounter this in the 6th century BCE with the Greek philosopher Pythagoras. But the Babylonian tablet, Plimpton, 322 dates from more than 1,000 years before Pythagoras. It contains sophisticated number combinations we now call Pythagorean triples. The point is not that Greece should disappear from the story. The point is that Babylon should be allowed to enter it. Part 3. The formula with no human name. The quadratic formula carries no name, but its anonymity hides a long multicultural history. In 628, Indian mathematician Brahmagupta presented rules for zero and methods for solving quadratic equations long before modern notation. 2 centuries later, Al-Khwarizmi in Baghdad systematically classified these equations. The word algebra comes from his work, algorithm from his name. Part 4. The law Snell did not discover first. Snell's law explains how light bends. It's named after the 17th century Dutch mathematician Willebrord Snell. But 6 centuries earlier, the Persian mathematician Ibn Sahl had already described the law of refraction in Baghdad. His manuscript clearly shows the constant ratio governing light. The difference wasn't just who discovered it, but whose environment, with printing presses and academies, successfully carried the name into the future. Part 5. Pascal's triangle before Pascal. Blaise Pascal applied this triangle to probability in the 1600s, but the pattern was already ancient. In China, Yang Hui reproduced the triangle in the 13th century. In Persia, Al-Karaji worked with it in the 10th. It was a global discovery long before it reached France. Part 6. Al-Kashi and the law of cosinus. In some cultures, this is Al-Kashi's theorem, named after the 15th century Persian mathematician who provided its practical formulation. While European equations kept their names, Al-Kashi's name was largely dropped in the West, replaced by generic terminology. Part 7. Calculus before Newton and Leibniz. The usual story says calculus appeared through 2 European geniuses in the 17th century. But the Kerala school in southern India developed infinite series for sine and cosine 3 centuries earlier. Madhava of Sangamagrama was working with these ideas in the 1300s. Newton and Leibniz created a decisive synthesis, but the intellectual roots are geographically broader than the standard story suggests. Part 8. How Europe gained the power to name. Institutional survival was key. European universities and empires possessed the power to decide which texts would circulate. The power to conquer was connected to the power to classify, and the power to classify was connected to the power to name. Part 9. This is not a story of simple theft. Science rarely has one pure inventor. Ideas develop through stages. One civilization finds a pattern, another proves it, another names it. Science is a human conversation across centuries. Greece learned from Egypt, Islamic scholars expanded Indian knowledge, Europe translated Arabic works. Part 10. Why this matters to students. It matters because education teaches more than equations. It teaches who belongs inside the history of intelligence. Restoring these names doesn't diminish European achievement. It makes science larger. It tells students that curiosity was never owned by one continent. The problem isn't that European names are false, it's that the map is incomplete. Enormous regions of human achievement have been erased. Science was never Western property. It was Babylonian clay, Indian verse, Persian geometry, and countless unnamed observations by humans trying to understand the universe. Correcting history opening the textbook wide enough to include everyone. Because when we restore the missing names, we are finally beginning to tell the true story of science.